So in first lecture, we are studying the communication system block diagram. Now we taking the example of communication system here. So the best example of communication system is a telephone. So when two users or when two telephone users they are communicate with each other, then uh, this type of communication is done through the uh, exchange offices. So telephone one is the transmitter or acts as a source, while telephone 2 acts as a destination. So the data, the voice, which is generated by the telephone 1, it is converted into the electric form and given to the exchange office. Exchange office actually work as a transmitter or encoder. So it converts the information and send on to the local connections called as the medium or communication channel. The exchange office second acts as a receiver or demodulator here. So it converts the information back to the user understandable format which is given to the telephone second. So the telephone one is a source. Local exchange office first is a transmitter. Local exchange office second is a receiver. Telephone 2 is the destination. So this system is equivalent to the our communication system block diagram. So let us consider. So the telephone one is acts as a source which generates the information voice and placed onto the or given to the transmitter. So the microphone of the telephone one and exchange office together makes the transmitter, while the telephone wires they are connected between two exchange offices acts as a communication channel. When the signal is transmitted from one exchange office to the another, then there is environmental noise, any noise which is added onto the communication channel. So there is a distortion in the cables acts as a noise. Then the telephone 2 or exchange office 2 acts as a receiver. So the information is back converted into the sound, and obviously telephone 2 user 2 acts as a destination. So this is the equivalent concept which is given here regarding the basic communication system. We already know that noise is the unwanted signal or undesired signal that is added into the signal while transfer the signal through the communication channel or medium. Generally, noise is a high frequency electrical signal or spike. Here, you, you are seeing that there is a noise which having the spikes of high frequencies. So there is a noise in TV also. So look at the black and white TV showing this type of noise due to the distortion in the signal. So these are the some examples here or noise. So noise is broadly classified as a external noise and internal noise. So in external noise, there are atmospheric noise, extraterrestrial noise, industrial noise, man-made noise is there. In internal noise, there is thermal noise, short noise, transient time noise, and partition noise, flicker noise, etc. So the atmospheric noise, as the name given to this, the atmospheric noise is the radio noise caused by the natural atmospheric processes, primarily lightning discharge in the thunderstorm. So when there is a lightning in the sky, so due to that there is a creation or generation of the noise called as the atmospheric noise. These are the radio signals or radio waves which are generated by the lightning in the sky. So second one is the extraterrestrial noise or space noise. So the extraterrestrial noise comes from the sources in the space. There are many sources of the space noise, broadly classified as solar noise. As the name, sun is the source of energy which radiates the energy which is in the electromagnetic spectrum or over the electromagnetic spectrum. So it repeats the noise cycle after 11 years. When noise peak occurs, sun produces the large amount of noise that causes tremendous radio signal interference. So when we are looking the TV in some March May month, there is a one type of uh, instruction or notice given by the what we say that TV channels or TV cables that there is a sun interference, so signal cannot be received at the your dish TV. So this is the solar noise. Then cosmic noise is the noise generated from stars, galaxies. So quasars are typically more than 100 times brighter than the galaxies. So the pulsars, quasars, or galaxies, they generate the noise or radiations called as the cosmic noise. Also, they are in the range of electromagnetic spectrum. So next one is the industrial noise. Industrial noise produced by the manufacturing equipments, hence it is known as equipment noise. Any electric equipment that causes high voltage or current to be abruptly switched, it produces the transient that creates the noise. So when we on or off the equipments having very large voltage and large current, then there is a industrial noise or current is switched abruptly, so it creates the noise. So this is the one type of industrial noise, can be a ignition system, electric motors and generators. It is in the range of 1 to 600 megahertz. So the atmospheric noise, space noise cannot be eliminated, but sometimes the industrial noise can be eliminated by using different methods. There is a man-made noise. The main source of man-made noise is the pollutions or ships, aircrafts, seismic exploration, marine construction, drilling, motorboats, etc. So these are the some uh, external noise which I have studied here. Then obviously there is a internal noise sources. The noise inside the device or inside the they consider to be a internal noise. So the electric components or electronic components such as resistor, diodes, transistors are the major source of internal noise. So the internal noise is the distributed over entire EM spectrum, can be classified as thermal agitation noise. It is found due to the heat. The atoms and electrons in the electronic component move randomly. So there is a atom. We know that atom is the basic element of the material. So when uh, heating is there or some electrons move randomly in the atom, so it creates the thermal agitation noise. The noise power developed across the resistor is directly proportional to the temperature and the bandwidth. So thermal noise created in the resistor whose noise power is directly proportional to the temperature and bandwidth. So if temperature is increasing, the noise power is also increasing, or if temperature is increasing, the bandwidth is also increasing. So it is proportional, directly proportional to the temperature and bandwidth. The thermal noise also called as the white noise or Johnson noise. So look at the equation. The power of noise or power in noise is equal to alpha TB, where power in noise can be calculated as Pn equal to kBt, where k is the Boltzmann constant. The value is 1.38 into 10 to minus 3 joule per Kelvin, where T is the absolute temperature in Kelvin, which is added with 273 to the degree Celsius, and B is the bandwidth in Hertz. So this is the formula for finding the power of noise in a or thermal noise. Then short noise. The electric components such as transistors and vacuum tubes are main source of the noise. Short noise produced by the random arrival of the electrons or holes at the output of electrode of an amplifying device. So the amplifying device may be a transistor, may be a vacuum tube. So when there is a transistor or vacuum tubes uh, is connected to the supply, then there is a process of amplification. At the amplification, the holes and electrons they travel towards the output terminal. So the formula is IN square root of twice EIPB, where IN is the RMS value of the short noise current. E is the charge of electron 1.6 into 10 to minus 19 coulomb. IP is the direct diode current. B is the bandwidth of the system. So from this relation, you can calculate the short noise of the transistor or vacuum tube. Then transient noise, transient time noise in upper frequency range, very high frequency range, and beyond the time taken by the electron to travel from emitter to collector of the transistor becomes comparable to the period of signal being amplified. Then transient time effect takes place. The time taken by the electrons to reach the output from the input of the transistor creates the noise. The transient time noise is directly proportional to the frequency of operation. So Tn is directly proportional to the F. So we can calculate from this equation transient time noise due to the time taken by electrons to reach the output from the input of transistor. So there are some noises which are created when the current is divided. So the partition noise is one of the example where the current divides into two parts or two ways or two paths. Then it creates the partition noise. Also there is a flicker noise. Flicker noise already low frequency noise, which is created due to the fluctuation in carrier density while modulation. So the modulation is the different topic. When there is a modulation, the flicker noise arising due to the fluctuation in a carrier density. So these are the some examples of noise sources. So today we are studying, or today we are studied uh, different one of the example of basic communication system, and uh, it analogy or it is analogous to the basic communication system, which is telephone system. Then we are classified the noise or studied the noise on the basis of types: external noise and internal noise. So go through the slides and you can write this information slides into your notebook. So we just stop today, and next lecture will be on the electromagnetic spectrum.